Hello, this is Ray. I'm going to show you the zero knowledge Sudoku game that I built. So here I have a front end that you can play the Sudoku game, and every time you hit the new game button, like it just gives you a random new Sudoku board, and of course you can try to like solve it, and then you can validate the solution, and then you can also for convenience, I just have a button that fill in the solution. You can validate it, and then let's say now you are ready to verify your solution. And let's say you want to verify with Alio. And then what you do is first you put your private key here. Well, I know you should never give out your private key, but now like Alio is still in its infancy, and then the tooling isn't mature. And also I'm just like running a local Alio node here. So I just like basically I send my private key and my solution to backend and have the backend to make the like the interaction to the Alio local node for us. So that's why like I pass in the private key here. But basically, I think in the future, like there will for sure be some like something like MetaMask where you can just sign the transaction and then send it to like some Alio endpoint that you can use. But anyway, okay. So once you are ready to verify your solution with Alio, you just like put in private key here, and then okay, it's correct, and verify for Alio. Just click that, and then what it does is basically it's sending your puzzle and solution and private key to backend, like as I described. And then what the backend does is basically calling the SnarkOS developer execute Sudoku Alio and solve puzzle and pass in the puzzle and pass in the solution that you have. And so basically, I have a local SnarkOS running. It's a local dev node, and then yeah, you can see we have the records keep and block keep being produced here, and then I can also show you the Alio program. Okay, so here's the Alio program. So basically, you can see like the backend is calling the solve puzzle transition, and what it takes is a puzzle. A puzzle. Okay, I guess first I should talk about like what structs we have. So we have like struct 9 numbers, essentially just holding 9 numbers, and then puzzle info, which is like just 9 rows of 9 numbers, so that like in total like you have like 81 numbers. It's a Sudoku board. And then we also have puzzle. Puzzle is basically a record that has owner, case, and solve, true or false, and like what's in the puzzle. Okay, so once we have the puzzle and the solution, and basically for puzzle, like for empty cell, it would be just like 0 here to represent like it's empty. And then so first we verified that each row in the solution is actually, well, first we verified that the solution is actually solving the puzzle, which means like that the fields, well, the cells that is in the puzzle that is non-zero indeed match the what's in solution. Otherwise, someone can just like submit like 1 2 3 4 5 6 7 8 9 and for all rows. And I mean, it's, yes, it's a valid Sudoku, but it's not a solution to the puzzle. So yeah, we check that, and the logic there, I think it's basically it's just what solution match puzzle. Okay, let me just like jump to the, I guess, definition there. Yes, I think it's just basically checking for each row, and then for each cell, if the puzzle has like number 0, which means like it's need to be filled in by the player, then okay. And if not, if it's non-zero, then make sure that like the puzzle number and the solution number match. Okay, so that's what we do first. And then I have a helper function called isValidLine. So basically what we do next is just checking like each row is valid, and then each column is valid, and each subgrid is valid. So for each, so to check that, basically I just check that for basically for each row and for each column and for each subgrid. I want to make sure that basically like 1 to 9 is present, and so there's a is valid line there. And what I do here is basically I just bubble sort the line, and then like, well, for now Alio hasn't support arrays, so basically I just have a 200 line bubble sort that sort 9 number, return a sorted like 9 number struct. And then here I'm just like checking whether like 1 is equal to 1 and 1 is equal to 1 and 2 is equal to 2, and so on and so forth until like all 9 numbers is like correct. So yeah, we do all that, and then eventually we return a puzzle record, and the solve, like true or false, is just like if all rows are valid, columns are valid, and then subgrids are also valid. And I also return like the puzzle. um, back to the record. Yep. Okay. Yeah, so that's our Alio program. And then yeah, indeed, like you can see here, we have the Snark OS response. And then let me copy this transaction ID. And then I can go to another page. Well, and then what I do here is I paste in transaction ID. And I can get this is like a helper UI for me to like explore like a local alien node. And then okay, proof. Yep. So basically what I can do is I can like copy this like ciphertext record output and then put it here. And then what I do is let me grab the um, view key for this account, I believe. I think it's this one. Let me see. Decrypt. Okay, yep. So basically what you can see here, you can see that the solve is true and we have like the original puzzle here. And I guess maybe I should also like put the solution in here. Yeah, I think I should also put the solution to the puzzle here. Like I mean in the return record, so that like the user can verify that hey, indeed, like server is actually, actually not really because well for now I send this thing to server. Like for now I'm like verified for ADO like hitting it back in, but I think in the future like the client can just actually call this like transition function like by itself. So yeah, I think this should be fine. So yeah, I think what it does is basically it has a like transition that basically prove that a puzzle is solved without revealing its solution. So yeah, that is about Alio. And then okay, now with NOR. So NOR, basically similar when you click verify with NOR, and then what it does is basically it's hitting our backend, and a backend that has a what? Let me see. Backend, yep, NOR and Sudoku. Okay, so yeah, basically what I have is I already have a NOR code that is a circuit that verifies the solution of a Sudoku. So you can see here is like the NOR code. Basically, I think it's like copy from someone has already implemented. I just like copy it, and then yep. So basically, check puzzle and then check line. Yeah, I think similar logic here. And then I also deploy the so basically I think I serialize the well I have a code. I have code that basically output the ACIR of the circuit, and then I put it here in the backend, and then I have the backend read that and then use that to generate a proof. So basically the client send like the request like solution and puzzle, and then the server generated proof, and then the server returned a proof to client, and then once the client got the proof, and then basically it's calling, yeah, once the client gets the proof, it's basically connecting with MetaMask, and oh yeah, and I already have the smart contract like deployed on a local well yeah, on a local Ethereum like node, dev node, and then basically this front end is just like calling that verify contract, and then you can see that basically the okay, it's an error. Okay, could not okay, memory. Okay, I guess let me just rerun it again because sometimes that could happen. And okay, let me just try this again. Doing solution, verify nor, and let's just wait. So yeah, and basically the smart contract for this circuit, I just like generate using the TypeScript wrapper for NOR, and then yeah, so here's the Sudoku verifier, and then so this is this has been deployed to the local Ethereum dev node, and yeah, you can see like now the Sudoku verifier smart contract is like it responds like true. And if I just like try to change a solution, and then like now it's incorrect, and then if I try again to verify with NOR, and you should see that like it should yell at you for with errors, yeah, like that, proof failed. So yeah, so essentially we have the backend generated proof and pass it back to frontend, and the frontend can send the proof to a smart contract verifier to verify like the correctness of the proof, like that is the correctness of the Sudoku solution. And also, like if you notice in our NOR circuit for Sudoku, the solution is private, the puzzle is public. So basically, in the proof, you can see the puzzle, but you cannot see the solution. And then like after like it runs through like all this code, and you can like make sure that the solution is indeed a solution to the puzzle. And yeah, I guess like later on you can maybe have like other smart contract, like just like call this verifier contract as like a helper contract to verify that the solution is correct. And once it's correct, then maybe you can like issue someone a token or like some NFT or whatnot. But yeah, that's basically the idea. And I guess I haven't shown you what would happen if the solution is incorrect and called up Alio. So yeah, let's do that. And then yeah, let's see. Uh, okay, and yeah, so now um, anything that you want to do with Alio is basically it will take some time, and I hope that it will be improved over time. So yeah, basically you can see, yeah, I think it's a better example to show you like what the puzzle and solution looks like. So puzzle is like basically a 9 by 9 2D array, and then for cell that is like empty at first, it's just like 0, and the solution is just like a full-blown solution. Okay. Okay, yeah, so it's calling it with the solution and the client private key, and again, hopefully that will not be required in the future. Okay, and then so the Alio backend is okay now. So the system call complete, and then basically it's trying to grab the okay. So now we have this transaction ID, and then okay, that's again go to the tool that we have here and submit. And then basically here, okay, we have the record here, and then okay, we can check the record, and you can see that the solve is false. Okay, yep. So yeah, I think that's it for the Sudoku demo.